Hello everyone, welcome to my channel. I am Ravani Haridas, working as an assistant professor in Electrical Engineering Department at MMA NTC Malegaon. In this video, we will discuss about the phasor diagram for directional element in induction type directional relay. Now let us study the phasor diagram to understand the directional characteristics of the relay. Let V be the applied voltage to the relay through PT and it is a reference quantity, and I be the relay current through CT. The system current is generally lagging the voltage, but with suitable connection the relay current is made to lead the voltage by an angle of theta, and therefore in the figure current I is shown leading the voltage by the angle of theta. Here phi V is the flux due to the voltage coil and it lags behind the voltage by an angle of phi. Similarly, phi I is the flux produced due to the current coil and it is in phase with the current phasor. We know that the torque is produced because of the interconnection of the two fluxes. That is, here the torque is produced because of interconnection of flux produced due to the voltage element, that is phi V, and flux produced due to the current element, that is phi I. Therefore, T is proportional to phi V phi I into sin phi plus theta, where phi V is proportional to the voltage and phi I proportional to the current. The torque is maximum when the two fluxes, that is phi V and phi I, are displaced by the angle of 90 degree. That is, when the theta plus phi is equal to 90 degree. So here the dotted line in the phasor diagram represents the desired position of phi I, that is nothing but the maximum torque line. Here the V is the reference quantity and therefore phi V has fixed position with respect to the voltage for a particular design. So the angle between the dotted line and the reference quantity V is known as the maximum torque angle and it is denoted by tau. Now the zero torque will occur when sin theta plus phi term will be equal to 0. That is, phi plus theta is equal to 0 degree or 180 degree. This being satisfied when the relay current phasor lies at right angle to the maximum torque line, and thus the directional element will provide the current phasor lies within the plus minus 90 degree of maximum torque angle. So here you can see this is the zero torque line and the operating region as well as the restraining region, or you can say it is the non-operating region. The directional element will operate provided that the current phasor lies within the plus minus 90 degree. You can see in the figure, if it is displayed more than the 90 degree, then the element will restrain. That is, in the figure it is shown by the non-operating. Now let us see what do you mean by the maximum torque angle. The angle between the voltage and the current at which the relay develops the maximum torque is called as maximum torque angle and it is denoted by tau. From the figure, we can write phi is equal to 90 minus tau and let this is equation number 1. Also we know that the torque is proportional to phi V phi I sin phi plus theta and let it is equation number 2. Now putting equation 1 in equation 2, we will get T is equal to K phi V phi I sin theta plus 90 minus tau. Here the sign of proportionality, it is replaced by the constant K. So finally we will get T is equal to K phi V phi I cos theta minus tau. When you refer the universal torque equation, you can see this term, that is the element which produces the directional torque. These are the references.